So what we did so far was solved the inequality 2x plus y less than 1 and 2x plus y less than or equal to 1. There was not much of a difference other than a dotted line for the strictly less than and a solid line for the less than or equal to. Remember that the boundary of the solution set is the straight line. When you have a linear inequality in two variables, the boundary of your solution set is the pink straight line, which is 2x plus y equals 1. So you have to first plot the straight line. You could use the intercepts or you could use the two points, whatever is easy and whatever is convenient. Avoid fractions if possible. Half was an easy fraction, so I just went ahead with the half. If not, you can plot a different point with whole numbers. And once you get 2 points, a minimum of 2 points is required to construct the line or graph the line, straight line. And then, of course, I said that the straight line divides the entire coordinate system, the xy plane, into two parts, and the boundary of the two regions, region 1 and region 2, with the boundary being the straight line. Now, if it's an inequality, we have to shade. It's like many points that form the solution. It is infinitely many points. It's a whole region that you have to shade. Now, the straight line divides the plane into two regions, 1 and 2. You just have to figure out which region needs to be shaded. It's one or the other. That's it. So what you do is pick a sample point from any one region. If the sample point satisfies the inequality, which means if you get something like 0 is less than 1 and it is a true statement, then 0, 0 lies in the region of the solution set, which means you need to shade the entire region that contains the point 0, 0. So 0, 0 was in the second region, so we shaded the entire region. Now, what if we had to solve the inequality 2x plus y is greater than 1? Okay, let's use a different color. Let's say 2x plus y is greater than 1, or 2x plus y is greater than or equal to 1. We're already done with the first step. The first step always is graph the line. So we're done. We already graphed the line. I'm going to see if I can get rid of the shading. Now, once you graph the line, we've discussed this earlier. Let me just change the inequality now. Let's say it is strictly greater than, not less than, but greater than. So we could do the exact same thing. We plug in the point 0, 0. Plug in one sample point from one of the two regions that this line divides the entire plane into. It's either from region 1 or region 2, but pick an easy point. Okay, so that's region 2. We pick an easy point, 0, 0. Plug it in. 2 times 0 plus 0 is greater than 1. 0 is greater than 1. Not true. You picked a point, you plugged it in, and you got a statement that is not true. What does this tell us? That region 2 is not the solution. It's region 1. So what do? We shade region 1, which is the other side. So if I have a solid line, now technically I'm graphing the solution for 2x plus y greater than or equal to 1. Remember that this region contains infinitely many points, unimaginable. It's infinitely many points. Just like the straight line contains infinitely many points, you can imagine that if I'm shading the entire plane on the right side of the line, it contains infinitely many points. Now, what if I wanted to graph the solution for 2x plus y strictly greater than 1? Then what's the only difference? Instead of a solid line that we have here, this is the solid line that we have here, we need to change it to a dotted line. That's the only difference. So what we have is a dotted line, and the entire green region on the right is a solution to the inequality, the linear inequality in two variables, which is 2x plus y is strictly greater than 1. We're going to graph the inequality, linear inequality in two variables. So linear because the power of x and y is both equal to 1, and that would give us a linear inequality in two variables, and the two variables are x and y. Remember that the step 1 is always graphing the linear equation. So which equation are we going to graph? 4x plus 2y equals 8. And we could pick 2 points to plot and then join the 2 points with a straight line. Easy points would be the intercepts. So let's find the x-intercept, and for the x-intercept, we plug in y equals 0. So 4x plus 0 equals 8. Four x equals 8. X equals, dividing both sides by 4, you get x equals 2. So 1 point to plot is 2, 0. Y is 0, x is 2. Next, let's do the y-intercept. And for the y-intercept, the x-coordinate equals 0 because it sits on the y-axis. On the y-axis, the x-coordinate is equal to 0, and that's what we use. So 4 times 0, we know the x is 0, plus 2y equals 8. This becomes a 0, so that's 2y equals 8. 2y over 2 equals 8 over 2, dividing both sides by 2, and then y equals 4. So the point is 0, 4. So we have the 2 points. Let's plot the 2 points. The 2 points are 2, 0. So let's say this is 1 and that's 2. So 2, 0 is this. That's the point 2, 0. And 0, 4. So 1, 2, 3, 4. So let's say that's a 4. And 0, 4 sits on the y-axis because it is the y-intercept. Now we join these two with a straight line. So this is 2, 0, and this is 0, 4. This is how we plot the equation. We join these two with a straight line. Okay. So this line is our boundary. Now the boundary could be a dotted line or it could be a solid line. Let's do step 2. And step 2 is getting a sample point. I like to pick the origin because it's easy. So my sample point is 0, 0. I'm going to test it. I'm going to see what happens to the inequality and the inequality is 4x plus 2y is greater than or equal to 8. We plug in the 0. So 0 plus 0 is greater than or equal to 8. 0 is greater than or equal to 8. Wrong, right? 0 is not greater than or equal to 8. So therefore, what that tells me is, let's label the regions. Let's say this is region 1 and this is region 2. Remember that we need to shade one side or the other. We plugged in 0, 0. It did not work. What does that tell us? The side that is opposite to the 0, 0 of the region that contains 0, 0 is shaded. So we shade region 1, and that region 1 satisfies the inequality that we want. The solid line, the solid blue line which we graphed, is the boundary of that region. It goes up to the point, so you have to shade up to that point. It's not great, but the entire region, everything to the right, has to be shaded. Okay, so if our graph ends here, just remember that the graph ends, but the plane really goes on and on, because that's what the arrows say. That's the region that represents the solution to our inequality. Now, what if I changed the inequality to 4x plus 2y is greater than, strictly greater than 8? Then the only change is you have a dotted line instead of a solid blue line. The dotted line tells me do not include that one line. Everything to the one side of it in region 1 is included, and that is your solution set. The green area, which contains infinitely many points, is the solution to your inequality 4x plus 2y is greater than 8, strictly greater than. Solid line for greater than or equal to, dotted line for strictly greater than.